Welcome. Welcome to a short lecture on how we can use Earth observation for sustainable development on Earth. This lecture is given here at the Technical Museum, and it's organized by ESERO Sweden. That is an initiative by the European Space Agency, ESA, and the Swedish National Space Agency. ESERO wants to enthusiast and serve as an inspiration for young people using space as inspirational source to increase interest in technology, in natural science, and in mathematics. And you will find a lot more information about ESERO at esero.se. So I will give you a short, I wouldn't call it lecture, but an overview on how we can use Earth observation to observe our Earth and why do we do this. My name is Karin Holmqvist, as you can see on this slide. I work for SSC, Swedish Space Corporation, that is part of this ESERO project. Just very briefly, what is Swedish Space Corporation? We are a Swedish company. We're owned by the Swedish government. We have 4 different business areas. One is data analytics, which is very relevant to this topic that we're discussing today. The other one we call rockets and balloons. We launch rockets and balloons to space, mostly for research purposes. So you attach an instrument of some kind to a platform that you launch with either a sounding rocket, which is a rocket that goes up to space and then down again, or with stratospheric balloons, which are really huge balloons going up in the stratosphere. So they are as huge as big as the I don't know if you know the globe here in Stockholm, but it's almost that size. And that is also to perform measurements of the atmosphere and stratosphere. We will soon also be able to launch rockets to put satellites in orbit around Earth, which is also very relevant to this discussion that we will have today. We have a global network of ground stations, which are used to receive data from the satellite. And then we also have, obviously, personnel. With this, we mean that we have consultants that can help customers of all kinds to work through the full chain from when you have the first idea of a mission that you would like to perform until you launch something up into space, you receive data, and you do something with the data. So we can help in all that, in that full chain. So to give you an overview of what Earth observation is, and a bit more of European space in general, I will show you a movie, a motion picture that ESA has made. You will see it very, very shortly.
High above us, some 800 kilometers above our heads, satellites are looking down at our Earth, collecting information. Information about the land, the oceans, ice, and the atmosphere. Why is this important? It's because we need to understand how the Earth works and to know more about how it's changing. These could be short-term changes like a shift in the weather, or long-term changes affecting our climate. When it comes to monitoring these, the great advantage of a satellite is that it can cover the entire planet and do this again and again on a regular basis. Satellites can collect visual information. They can also collect information that will be hidden to the naked eye. ESA is at the forefront of satellite Earth observation. For example, our Earth Explorer satellites are finding the answers to urgent scientific questions questions about the cryosphere, that's the Earth's ice and frozen ground, about gravity, about moisture in the soil, the salinity of our oceans, and about the Earth's magnetic field. ESA's Sentinel satellites support the Copernicus program. Copernicus will help us see the impact of changes in the ozone layer and changes in sea level. Over 30 satellites will provide up-to-date information to help governments respond quickly to disasters and emergencies, to plan our cities, to monitor water demand, to check air quality. Copernicus will help us see the impact of changes in the ozone layer and changes in sea level. ESA also develops meteorological satellites for weather and climate studies, together with the European Organization for the Exploitation of Meteorological Satellites, or EUMETSAT. All this information gathered by our Earth-observing satellites is hugely valuable in advancing science and technology, supporting European industry, and fostering international collaboration, caring for our planet and for the people who live on it. That's at the core of ESA's Earth observation program. And the cost? To run the whole of ESA for a year costs less than the price of one cinema ticket for every European.
So we all contribute with one cinema ticket per year to European space activities. You could also see in the end there, you saw the Swedish astronaut Christer Fuglesang with a Swedish flag on his arm. So what is actually Earth observation? As it says on this presentation, it's a collection of information about the Earth's physical, chemical, and biological systems. By that, we mean that we collect different kinds of data that will give you information of different things, different systems that all affect the Earth and how the Earth is and how it develops. So how do you actually observe Earth from space? Well, as I mentioned earlier, we send satellites up in orbit to orbit Earth. These satellites are actually platforms on which we put payloads or instruments of different kinds. When it comes to Earth observation, these instruments are sensors that will measure something and then send data back to us on Earth. And these sensors can be radar sensors, for example. It can be optical sensors. And with optical sensors, you can almost see like a real picture as we imagine them. So almost like a photograph. The Earth observation satellites orbit the Earth at low altitudes. As they said during this ESA film, is about 800 kilometers. It can be up to 2,000 approximately kilometers, which is quite low orbits. To cover the full surface of the Earth, you need to have this satellite in an polar orbit. So you need to always go around the poles to cover the whole Earth. There are obviously different kinds of orbits as well. But in this case, if you want to monitor the whole surface of the Earth, that's where you need to be. You can have a geostationary orbit, for example. If you want to look at just one spot over the Earth, then you have to have the satellite move the same direction and the same speed as the Earth. Then you will always monitor the same point of the Earth, for example. But that's not the case here. these Earth observation satellites, they move rather quickly. They will orbit the Earth approximately 14 times during one full day, so 24 hours. That's rather quick. So I mentioned radar and then mentioned optical sensors. So there are different kinds of sensors that you use to learn different things about the Earth. You see different things. Some of them you can see with your eye, or you could have seen them with your eyes if your eyesight had been as good as those of an optical sensor. But some of them are not visible to the eye. So for radar, for example, which you can use also to look through cloud cover, for example, which you cannot with optical sensors. So the kind of sensors you choose depends on what you actually want to see, what do you want to measure. And quite often you need to combine different kinds of sensors, well, actually different data from different kinds of sensors to get to the result that you're interested in. I mentioned radar. I mentioned optical data or optical sensors. There are also, for example, near-infrared sensors that you can use for other things. The near-infrared is very close to the visible wavelengths, but it's not really visible. So you can measure different things with these. There's also different resolution on different images. At this picture, you can see 10-meter resolution, for example, which is a bit blurry. 10-meter resolution means that 1 pixel is actually 10 meters. 5 meters, then 1 pixel is obviously 5 meters. You can see things that are 5 meters in size, approximately. And then you have the 50-centimeter resolution, which is very sharp. You can see 50-centimeter sized things. So you still can't actually see a face or anything, but you can see things that have this size approximately. The 10-meter data is what you can get from the Sentinel satellites that were also mentioned during the film. And this data is free, it's open, you can use it for anything, so it's available to anyone. And actually, often that is enough. For many applications, you don't need higher resolution than that, but for some you do. And in that case, you will have to pay for higher resolution images. Quite often you use these quite low resolution images, and then when you find something interesting, you buy data over that specific point of interest, so you don't have to spend a lot of money on data that you're not interested in. And artificial intelligence is a bit of a buzzword, but it is very important. When you look at satellite data or Earth observation data, in this case, you will get tons of data. You will get so much data, and you will need to be able to sort out what data is relevant, what is not relevant. You will need to find patterns in these data, and quite often you combine data, as I mentioned earlier. You combine them in different layers, and you use AI for this. You use AI to identify interesting parts of this data, for example. And with this image that I'm showing now, it's a very simplified usage of AI. But in this case, you can look at the big picture or the big image, and on your left side, and then on the right side you can see parts of that image that you can then identify by using artificial intelligence in different ways. So as I said, it's very simplified, but you can see the forest, you can see a river enlarged, you can see what parts of this is agriculture. So you can identify different kinds of areas using AI, for example. You can do tons of stuff with AI. So I'm going to tell you a bit about, as an example, what we do at SSE when it comes to services based on Earth observation data, and how we use AI for this. We use AI to analyze satellite images and to analyze them in depth, so on very detailed level. And when we use this information in the right way, we can help organizations to make their decisions in a sustainable way, or to make sure that they perform their business in a sustainable way. This could be, for example, that they, in their supply chain, make sure they preserve environment, that they work for biodiversity. We use this to drive social development, for example. And we can also monitor very complex supply chains using satellite images. I will give you an example of this. This is an example of a river in Indonesia, where we dye. Well, we don't, but the companies they dye textile, which is it's very not friendly to the environment. It pollutes a lot, and you can see here that in this image we detect pollution in a river. On the right-hand side, you see a purple string in the river, which is where we have detected this pollution. This is a very densely populated area. As you can see, there are a lot of houses, there are a lot of people living here. A heavy polluted river is probably not very good. So in this case, we can show the clothes manufacturer, for example, if that's the case here, how the supply chain how the dyeing will affect the environment in a very, very bad way, and they can take measures. They can do things to make sure that they affect the environment as little as possible. But if we don't have anything to show them, how will they ever know? So this is a very important tool to use to actually make fact-based decisions. And this is, I think, my last slide that I will show you. It's just to show you that Earth observation has very different and many usage areas. For example, on this image, you see agriculture. Earth observation data has been used for agriculture for quite a long time. For example, when you need to plan your fertilization, for example. When it comes to risk assessment, you can see ground movement, for example, using radar. You can see if you want to enlarge a city, you can use this for urban planning. You can see what is there today. How if I build a house in this area, how will that affect the areas around, for example, around that area? You can use it for a lot more. What's not stated on this image, for example, is that something I think you probably have seen it, all of you, how we have used, and with we, I mean the world, how we have used satellite images to see what's actually going on in Ukraine, for example. When they say that there are no troop movements, for example, we can see troop movements because the satellite images, they don't lie. For example, we can see how the refugees move, for example. And that's one of the really important things, in my opinion, at least, when it comes to satellite data, that this is purely fact. It's not someone's opinion, but we can actually see what is going on, really. And I think that's very important, especially in the world we live in today. That was what I was planning to tell you today. So thank you very, very much for listening. And after this, we can have a brief discussion, I think, and a bit of a workshop, right? Yes. So thank you so much for today.